Hello my friend, how are you? Good? Let me make it better. Today I'm going to talk about some of the questions in 2019 May. The paper got recently released and I like to go over some of the questions that student already knew before the exam. Oh, hold on a sec, it sounds like a scam, but it's really not. This person went to the workshop in the summer and the winter and then taken the notes from our class extensively. And you actually will be able to, you will see some of the questions that she already seen in the vacation came up for the exam. That way, she was readily able to answer the questions. Without further ado, let's have a look at some of the questions that she managed to answer from our workshop to her May exam. And here's the thing, I'm not going to talk about some of the easy ones. You know, you have 10 or 11 questions in the paper, and the first 2 or 3, just basic understanding, just give away questions, right? Like the remainder theorem. If it's perpendicular, then use the dot product, show that to find some constant. I'm not going to talk about that, but some of the key questions that were a bit of trouble for the students, right? So if you look at these function questions, this is a composite function questions. And a lot of questions ask about finding the domain of a composite function. Well, you all say that, oh yeah, we all know that, right? But then when it comes collectively, sometimes it might be troublesome. And to tackle these type of composite questions, she already went through some of the very, very similar questions. As you can see, square root composite with the rational function, and how we managed to find the largest possible domain finding by being able to sketch this. So that's the number 1, what she had already seen during the summer. Now let's have a look at these transformation questions. In the transformation, you have modulus domain transformation and modulus range transformation. You have modulus domain transformation and you have modulus range transformation. And for this one, as you can see, this is a logarithmic function with the absolute value of x. And as you can see, this is the modulus domain, and we should know how to sketch that the modulus domain. If you have a function, cut off the left part and make it symmetric from the right hand side. You will get to learn this a lot in details during our class. But here's my point. This is a modulus domain composite function. But what she has practiced in the vacation was something with the modulus domain and range of exponential function. And here's the thing. Yes, it might be a different function, but in the essence of solving the equation, essence of solving the intersection is the same, right? So she already seen the type and she managed to practice extensively, right? And every time you have a modulus function, always sketch. So she sketched the first and second function. As you can see, we sketch the exponential function and then make it symmetric on the y-axis and x-axis, and then solve the equation by using some of the key piecewise function for the modulus, right? And then solve the question. So here's the thing. Even though the function might not exactly be the same, but if you learn the essence of problem solving skills, such as the modulus transformation equal to sketching, then you have no problem whenever some weird function comes up. And here's a third example that came exactly the same as we practice during the summer. You know, complex higher roots, and you bring it down. That's roots of unity, easy peasy lemon squeezy. And then you are given some of the complex form, and you have to find the real part, find the Cartesian form, and then you're trying to show the real part being 0, etc. Standard questions. But here's the thing, you know, you get to learn a lot of different types of skills with the trigonometry into complex and being able to simplify. Right, so she has already learned how to convert these Cartesian forms and polar form, vice versa. And also some of the questions to show that the real part eventually becomes 0. So one of these things, right? You already have seen it before. And if you have seen it before, even the numbers slightly change, you have no worries because it's the same type of questions. And that's how we practice you during the summer and winter holiday season. Now let's have a look at the next question. I like this question. This is something with the differentiation, and every time they're talking about the rates, you should know that it's related rates, right? And there are a lot of examples in the related rates. You need to build, so you know, the related rates optimization, it is your role to build an equation. And then here's the thing, if you haven't seen many examples of related rates or optimization, and it might be sometimes difficult to build an equation, it's easy to differentiate because related rates, it's always the implicit differentiation with respect to time t, right? But if you haven't seeing some of this type of example and not being able to build up an equation, then it'd be quite troublesome. So notice some keywords: camera, right? Racing car, and then camera is spanning along the road. And when it's when it's the shortest distance, what's going to be the rate of change of spanning? That's what this question is all about, right? Let's have a look at our next notes. Check this out. Racing car, the speed is given, camera operate, spanning. Exactly same question, right? Exact same question. Numbers are different. Yes, doesn't matter. Building up the equation is exactly the same using the trigonometry. As you can see, it is impossible for her not to get 7 according to her notes taken, right? And that's how we manage to practice you. We give you a set numbers of essential questions for you to require to solve. If you manage to go through them, then you are Saiyan, Dragon Ball, right? You practice, you train hardcore, you carry a lot of heavy weight, and once you get into the battlefield, you feel a lot lighter. That's what we practice you, right? That's how we manage to show you the abundance of resources and manage to organize and then feed it to you, and then you just have to swallow and digest and be ready for your test. Here's another question from the 19th May. Normal distribution, everyone thinks that it's going to be only the calculator-based questions, right? So some people sort of skip through the normal distribution with the non-calculator-based questions, right? So there are some questions in the normal distribution where you need to use symmetry. And if you haven't practiced that, and if you see it for the first time, you will get confused because normal distribution, I must use a calculator. How do I solve this without calculator? And this is the paper 1, so this is sort of using the symmetry. And she already has seen the question using the symmetry, right? This is not using the calculator, but normal distribution, symmetry, hence sketching. Just a rough sketch of a symmetric curve and show you how to solve this with just some of the algebra, right? You subtract some of the part to convert between the less than, bigger than. She already has seen it before, right? So even in the paper 1, normal distribution, no problem. And this is a very, very popular questions, right? You got a curve, you tangent, horizontal to the x-axis or y-axis sometimes. Last year was horizontal, parallel to the y-axis, but that means the gradient is undefined, right? Then the denominator of the gradient function must be 0, etc., etc. Very popular questions. Implicit differentiation. And here's the thing. If you differentiate by implicit differentiation, then you have the derivative in terms of x and y. And even if I set the equation being 0, I might not be able to find the x and y because there are 2 unknown variables. And what do you need to use? Yes, you got to use the given equation. Hence, you set up it as the simultaneous equations. She already practiced a lot with different types of examples from the different years and knows that we need to build not only the derivative, but also use the original equation, right? So that hence you solve it simultaneously. One of these key things, one of these computations, she already knew. She already knew from our notes, from our class. See that? And then here is a question that was mixed with the trigonometry integration in 2019 May. As you can see, a lot of trig identity proving. Some people didn't manage to solve this, converting from secant tangent and the integration of a secant and tangent. And here's the thing, yes, if it's a hence, you got to use a previous identity right on. But otherwise, it's okay too, if you already knew the integral of a secant tangent, right? And then often, they don't get to go through the integral of a secant. For a fact, they only go through the secant square. But what I encourage students to do is to be able to integrate secant, secant square, and secant cubic. In that way, you get to learn the fundamental theorem of calculus, integration by parts, integration by substitution. And then he can be integrated by substitution. So, so this identity was required to solve this one, right? So I'm just giving you. But as you can see, you get to go through some of the key integration using the substitution secant, cosecant as well. It will be given in terms of a logarithmic composite function, right? This is a proof for that. And then if you already knew this, you wouldn't need the identity previously. So even if you didn't manage to solve that, you can still integrate the secant. Tangent, you already know how to integrate the tangent, right? So As I'm saying, she already seen the question before, even before the exam. As you can see, square or cubic, she already tested it. So even if it was given square or cubic, would have been no problem. Now let's have a look at the next question. This is a sphere cone inscribed. The cone is inscribed in a sphere. Talking about the maximum value. As soon as you see the keyword maximum, this is something about the optimization, differentiation, right? But as I've said, just like the related rates, if you don't know how to build up the equation, it's easy to differentiate, but I don't know who to differentiate, right? And optimization is a slightly more, I wouldn't say more difficult, but different from the related rates, because you need to make sure you convert the variables into the one variable, right? Related rates implicit, don't matter how many variables you have, but optimization, you gotta only have a one variable. And look at this, beautiful. She already has seen the question before, right? Exact same sphere and cone. And she knows how to build up the volume equation just in terms of one variable using the geometry. Make a cross section and use the geometry, right? So she already seen it before. As you can see, beautiful, beautiful. So whole my point here is that you would have already known the question if you went through our class. And PDF, continuous random variable in PDF, the example was given as arcsine in May 19. But you know what? Guess what? She practiced even harder function. I'll show you the next the practice she has made for the PDF. She was given xarcon. And as you do know, if you want to get the probability from the continuous random variable PDF, you just have to integrate, right? But if you haven't practiced this with more challenging functions like the inverse sine, the inverse tangent, as you know that you got to use the integration by parts, right? She already has went through. She has already gone through, right? As you can see, practice with arctan, came up with the arcsine, no problem. And as you can see, you know, arc inverse tangent, and you do the integration by parts. Beautiful, beautiful, right? Then being able to evaluate up to this simplified form. If you have practice with the integration with the inverse tangent, no problem with the inverse sine. And here's the most challenging question I think in the 2019 May. If you have attempted this before, if you haven't and you're studying statistics for the moment, please go through that. It's really, really nice question. I would call this as a mixed variable, right? The probability is not just given by one event, but it's mixed, right? And so the x random variable was distributed by Poisson, and then the random variable y of feeding the the cat depended on her visit. Feeding depends on the visit, so it's mixed. So if you have seen this type of question for the first time, I think this would have been very, very difficult, very challenging. But you know what? She already has seen it before. So let me show you this type of question that she has seen it before. A car company running a rental for the limo. So then there are two events here. The company has a limo, two limos, and the request. Limo request. Cat feeding. Do you see the analogy? Cat visit, feeding, limo, and request. So the logic of solving the question is exactly the same. Even though the words and numbers are different, no problem. If you have seen this mixed event questions, would have been no problem. And then, you know, for this guy, what you have to come up with is to create the similar probability distribution table, as you can see. Not only why, but also depends on the request and then the use of limo. So she practiced this, and it killed the question, right? So this is how we practice you for the great success in IB. There are a lot of great questions that come from different textbooks, right? So as you might have noticed, some of the textbook that was adopted from these notes, and I think this year it was hugely reflected on the Cambridge and IBID. IBID is a really, really old book, and I love this book. But I do have that clarity of distinguishing some of the books and being able to spot which topics is good for those books and teach students accordingly in the most efficient way. And then as she has managed to succeed in IB for the May 2019 by practicing a lot of questions, you can do it too. You can join our class in the summer and the winter or our online class and be able to gain this huge substantial information and ace it with ease. Right, so this is it for me today. I was so excited to have seen this paper and hear the news from a student that she did really well for the paper because she just saw a lot of questions before. And I wanted to give you guys the same chance by explaining our work and ask you to join our community. All right, this is it for me. I'm Groovy Math Wonjun, and I'll see you next time with more information. Ciao!